configuration, fill it, readings, it's really important as well. Sensitive data exposure, this also is a topic for the later or last attack. The missing function about access control, so defining functions that should be private but are public. In Ruby, it's not really there because there is a method in Ruby called send, which is a private method and allows you to inject any code. But there is also public send, which does exactly the same thing. So you can public send the send, and there are no functional access control. So you have to be really careful when you're using public send. The cross-site request for J is our last attack, and it allows you to change other people's content if they are logging on other websites, you may know. The using components with known vulnerabilities, such as Heartbleed, the shell shock attacks. We all love open source. In Ruby on Rails world, especially, we love open source. However, we tend to just gem install everything and use it without carefulness. So, yeah, we can't use the gems that are insecure. The unvalidated redirects and forwards. We'll talk about this later as well, but in short terms, people can inject into your code not only SQL, but also the headers. The headers also comes from client. So if you redirect to the HTTP referrer header, and someone will inject this header, like to malicious site or to phishing, and you redirect the user back, well, they end up in the phishing site. And it will stop, and we still get credentials. It's not their fault, it's not user's fault. It's our fault that we haven't protected them. Any questions to the top 10? Alright, we might move on then. A little word about our target application. It's going to be a simple Ruby on Rails forum. It's built on Ruby 2.3, Rails 4.246, and PostgreSQL 9.4. We won't bug with the MySQL because MySQL is really insecure. You shouldn't use MySQL probably on your adventure because it tends to compare, for example, strings with 0, and 0 equals any string is true. So, yeah, just be careful with MySQL. Here's our database command. It's really, really simple. Users can comment on the forum threads. User has many comments. Comments belong to the forum thread. Nothing special. Users are created using startup device gem. Any device users here? Great. Alright, so onto the first attack, SQL injection. Anyone heard about SQL injection? Okay, do you know if SQL injection is possible in Rails? Unfortunately it is. Unfortunately it is. So what is SQL injection? As this picture might help you, it's injecting code to the other people applications that can hurt their database. This is probably the oldest and most known about SQL injection. The Bobby tables. There is even a page called bobbytables.com that you can find your SQL injection information. However, there was some foolish attempts at SQL injection, which you may see here. This guy is pure genius, by the way, dropping the database table of the things that shoot photos when you drive too fast. I don't know if it was successful, but I really hope it was. Okay, so we're going to start with our application here. We have the forum threads controller, which is kind of standard. On the bottom you can see the resources, and we're going to start coding here. So please open your terminals, and we'll dive into the code. Of course, Tomek is here to help you with any issues that you might encounter on the way. So yeah, let's get to it. You have your Sublime text installed on the desktop. Right here, if you would like to use it. And we'll start with the simple forum threads controller with the show. And as you may see in the presentation, we're going to be redirecting users with forums title not using the ID. So we have to change it to use ID. So we're going to remove the find by params ID and replace it with the find by title. Alright. And here in the config routes, we have to change this to take care of param title too. And it's fine. Probably we should also take care of the view. So app views, it's actually going to be form index, I believe. So let's go here. Yeah. And here you have to add the title, third title. And this should take care about everything. So yeah, let's save it. And we're going to run into our application. So let's change directory to the hacking forum. By the way, if there is anyone that does not have the Git repository, oh my god, my access, sorry. You can find the repository here. I believe this is actually our GitLab. But it is on the GitHub Railwaymen/hacking forum, if you mind. Alright, let's set the Rails server in a very standard way. It's going to take a moment when it boots. Everyone is finished with the code writing part?
Could you back to ham index?
Yeah, sure. Here it is. Everyone fine? Tomek is probably typing the URL of the GitHub just behind me. Okay, seems like the Rails application is on. We can go to the localhost, colon 3000, save. Seems like we have a little bug here.
Sorry?
Yeah?
What's the path of editing file?
One more time?
Of the file you are editing now? The path.
Sure. We are in Home Hacker Hacking Forum.
Yes.
And we are editing the app controllers, the forum threads controller, which you may see here. And we changed this piece of code right here. We are also editing the config routes, which you may find here. Yeah, there's the GitHub local. And also the app views forum index handle, in which we added this little part here. Alright, everyone fine? Okay, we can wait a little. Yeah, sure. Next file. Here's the change you want.
Yeah, that's the folder.
And the config routes. pop-up here, the obvious for index point. And change your looking at this little.
Czy wszyscy mieli listę, czy jeszcze nie?
Okay, everyone ready? Okay, we're fine? Alright, so now start your Rails application here as bundle exec Rails server. We're in the Rails root directory, of course. So, yeah, let's wait a second for the Rails boots up. Rails booted up. Here you probably should see the main page. However, I'm not. Yeah, something's wrong. Let's see what's wrong, actually.
What?
No, there should be. No, just. Okay, I think I was messing previously with the database, so I'm actually going to reset the database here. By the way, if you are looking for the credentials to log in, you can find them here. So there are like 5 users with the user 12345 at example.com with the password just being password. And some forum threads, some comments, just basic things. In the meanwhile, yeah, seems like. And also for the people that were cloning the GitHub repo, you should of course run the migrations like that. And then to get the seeding information, you should seed. And they should create the files here. So let's actually restart. Alright. Missing requires this table. I don't know if I've saved it.
You need to save files.
Yeah, I think the subline didn't save them properly. Yeah, that was probably it. Yeah, that was it. Okay. So you can see some basic parameters here. We're actually going to create one by ourselves. So we're going to jump into the Rails console right here. And we're going to create the thread for our SQL injection attack. And we're going to just call it SQL for future reference. This creates the forum thread with the title SQLE. When we create the page, you can see the thread. Here it is. And we're actually going to spend some time here in the Rails console. So, let's look at the code we have in our controller. You can see find by title, params title. Do you see any vulnerability here? Does anything looks unsafe to you? I think not. I think it's perfectly fine. We can try to hack it. So, let's see how find by works. Let's find by title, SQLE, and you can see the SQL query being generated. It's really basic. It's just selecting using the where condition, which is important, comparing the title to the string you gave it. Everything seems fine. And in fact, meaning here, which often you can see in other people's code. Look carefully at the old code, which is okay, and the new code. What have changed? Yeah, there's a string. And there's something really dangerous, embedding the parent's title into string. And this can hurt badly. Let's see how it can hurt. So we're going to change it to find by title. Let's say SQLD. You can see that there's no longer embedding the title with the variable. It's going directly into SQL. Let's assign it to a variable called, for example, attack. And let's write the new code from the slides. It seems like I forgot something. Yeah, I forgot the columns here. There should be a columns in order to compare strings. So it seems fine. Now what we're going to do is what everyone came here to do. We're going to drop table. Yeah, dropping tables. So how do we drop table? We're going to change this attack variable, and what we're going to do is we're going to close this column, going to close this bracket, get a semicolon here, a drop table command, and comment out the whole letter field. Let's do just that. So we're going to close this with an empty string, close the bracket for the where, put a semicolon to end the SQL statement. Now inject drop table users and comment out any SQL after it. In PostgreSQL, the commenting out is done by 2 dashes. Yeah, here's our attack SQL. Let's see if it succeeds. We see that it had not. Let's find out why. I don't think it's the same error. One more time. You can see a syntax error. The comment cannot insert multiple commands into a prepared statement. Also, what you can see, which is really important, is that Active Record is totally fine with that. Active Record has no problems, which may seem that if you take another database, not a PostgreSQL, but MySQL SQL3, you may end up in getting dropping table. So it's actually not the Active Record that saves us, it's the Postgres that saves us. But why? Why didn't it succeed? If you look at the SQL, it looks perfectly fine, right? It's select, the statements end, here's the drop table, and any other stuff is commented out. It should succeed. But it didn't. It didn't because the PostgreSQL and its gem, its adapter, the PG gem, actually cares if you are getting dropping table. It won't allow any multiple statements like this is the first statement, this is the second statement. It won't allow that. So actually, the savior here is pggem. And thank you pggem for the prepared statements. But what are prepared statements? Let's go back to the console. The prepared statement is what you can see earlier this time. What you can see here. You can see that in comparing to the SQL we done earlier, now there is a variable. And what it does mean is that whatever we put here, we can put our SQL injection string here. It won't drop table because it takes this string just as para for comparability. PGGem way of doing things. There are many ways in any other code language, such as Java, C++, PHP, to do prepared statements. And you should always do prepared statements along your way while executing SQLs. It's really important because it protects you from SQL injection. So yeah, thank you PGGem. However, does that mean that SQL injection is impossible in Rails? As I asked you earlier in the presentation, you answered that yes, it is impossible. Well, unfortunately no. It is possible, but just not dropping tables. Let's see what we can do. So, in fact, people who do SQL injection on your side probably won't want to drop your table. Because dropping tables does nothing, right? Application will just go down, no big issue, the admins will build it up in no time. It's not dropping tables, that's actually dangerous. The database is what is dangerous. And unfortunately, there's no way to protect yourself as data leaks, apart from actually not using embedded strings. Let's see what is dangerous. Let's go back to the just SQL in. Here's our SQL. You can see that there's no prepared statement here, no whatsoever. And we already know that dropping table will not succeed, right? We tested it in there, it won't succeed. However, what may succeed is getting other foreign thread that we wanted. So let's create another one. Let's call it can be seen, for example. I forgot a column. And now what we're trying to do is to get this foreign thread using this title. It shouldn't ever happen, but it will happen if you will embed your strings recklessly. So, the title here is going to be again the malicious query. And again, yeah, let's do the attack again. So, attack equals. We're going again to close this, close the right bracket, but we're not putting the semicolon here. We're not ending the SQL statement because we know whatever we do after the colon will fail because the PGGem is protecting us. Instead, we'll try to get another title. So we're not closing the where. We're getting the close or 1 equals 1, which is always true. So whatever the title will be, comparison will fail with the title, but it will not with the 1 equals 1 because it's always true. So this statement will always be true. Let's order it, for example, by created at. Yeah, let's do descending order probably. Limit 1 is fine because we want just 1. Let's end the statement here. We should close the where statement here, I guess. And as usual, let's comment out other stuff. Should I explain it one more time? Everyone got it? Alright, let's see if it will succeed. That's an error, but it's a syntax error, not the multiple statements. Yeah, I haven't closed the quote, my bad. So attack string is actually going to be empty string for 1 equals 1. So let's put empty string here. Or 1 equals 1, close the order close, order by created as limit 1. Okay, now it should succeed. And indeed, you can see that we actually got the title, the foreign thread of the title we didn't know by injecting the SQL injection with this little or 1 equals 1 close. So the PGGem will protect you against the dropping tables. It will not protect you about embedding strings in your code. So what I want you to remember from this attack is to never embed anything that comes from user into your SQL. Because you might not get drop table, but the people can get information you don't want them to get. And well, in the end, hacking companies pay for emails, passwords, banking data. They do not pay for dropping tables. So just be careful and do not ever embed params into your script. Alright, let's close the first attack. For the further reading, I want you to check out this page, the rails-sqle.org. It is an encyclopedia of whole SQL injection vulnerabilities in Rails, Rails 3, Rails 4, probably Rails 5 coming down the way. And, well, it's really no safe active record method. Maybe find, but apart from find, every other is a room for an attacker. So if you will embed like order, params sort by, and you're sending the sort by condition to your order by to sort the tables in user's favor, for example, by date, by their name, by their surname, you're opening yourself to get SQL injection as well. So do not ever embed params into SQL, ever. Okay, any questions to the SQL injection? Also, if I'm speaking quickly, just talk. Alright. I guess we can move to the next attack, which is, this was, by the way, the top one of the vulnerabilities across the web from the OWASP. And now we're going to do the third one, the cross-site scripting attack. Anyone know how cross-site scripting works? Right? So how does it work?
Certain scripts on plain spaces which other people can see, comments or something like that.
Yeah, exactly. And we're going actually to use comments. So here's a basic comments controller. It's nothing special, just creating the comment. You can see the Rails for strong params here. And in the app views for threads show, there should be a comment content. Let's jump to Sublime here. Let's close this, it's no more relevant. And let's go here. This is the app views for threads show. And you can see just the list of comments. Actually, that HTML save shouldn't be there. Let's just remove it for now and save the file. There's nothing really to scare. Here's the comments controller. You should have exactly the same code as I have. So let's abuse it. We're going to the localhost and we're going to log ourselves as one of our users. For example, user1@example.com. The password is the password. There is 1, 2, 3, 4, 5 users. Just changing the digit here should work. Let's log ourselves in. We're going to use this fresh thread, the SQL injection one, because all others are clumsy with the C stuff. And here we are. So this is the commenting view, the simplest form you can ever have. Let's say something like hi. Oh, the form today. Okay, my bad. And this is actually the change we've done with the find by table. So you can just stop your server, git check out everything we've done so far with the SQL injection because we want our application fresh. So just git check out your whole code. Restart the Rails server and we should be fine. Alright. We're going to refresh the page with the title. Again, let's go back to root then. Get here. Say hi to everyone. Comment. Okay, far, so good. Let's try to get a link. For example, look guys, amazing site. Let's try to embed the link with the HTTP, let's say railwaymen.org. Check it out. And here, the link will render, and it's only because we have this HTML save. So, a little word about the HTML save. What does HTML save do is to trust you entirely. So, it won't anymore check your HTML. It will allow links, it will allow images, and it usually starts with that. It's usually the users that request you that, okay, your form is cool, but I want images, I want links, I want my custom signature. And they are not actually aware what may happen. So yeah, let's allow them. Let's add this little HTML save here that you may already have. And so it begins. This little method, the HTML save, gets a whole room of the vulnerabilities we're going to explore right now. So let's do a simple test. Let's do a simple alert. So let's go back to the application. Let's try to inject it. You can comment that code, and it succeeds. If you want the code of the alert, here it is. So let's talk about why we alerted. This is probably the first way you will think when you want to, just check if you can execute script. That's alert. However, alerts are not really cool, because everyone that will see this page, and people will see it because it's forum, will get this alert. Probably they will tell about the alert admins. Probably admin will find the spot very quickly, will remove it, and will ban us for trying to hide their site. So, alerting is not really fun. Let's do something more. Let's do something fun. Let's become admin by ourselves. And we can do that by stealing the admin cookie. The script you can see here is actually the simplest way of doing the AJAX request. Everyone knows what's AJAX? Right? Good. So it's the easiest way of performing the AJAX request to the server. And we're actually going to write this server by ourselves. Not using the writes because it will be an overkill to use write just for one collection. Let's actually use the Sinatra. Anyone knows Sinatra? Okay, one person. The Sinatra is the really simple Ruby intro framework based on Rake, of course, that allows you to write really simple servers. One file servers, as you can see here. What this little snippet of code will do is to define only one action that logs the cookie to the file. It's probably the simplest web server you can have here. So let's write exactly that in our server. The file of the Sinatra, I think you have to first install it. So let's install the Sinatra. Go to your gem file, type gem Sinatra, save it. Go to your terminal, let's exit the REST console for now, and type bundle install. And hopefully our internet won't break down right now. Hopefully. I've got the gem cached. Tell me if you have any internet problems while installing the gem. It might take a while. Okay, it should not. It's a really small gem. And we will proceed when everyone will be finished with downloading. I will use this time to actually water myself. Alright, everyone have Sinatra? Someone's waiting for the download?
Not yet.
Sorry?
Not yet.
Not yet. Alright, let's start when you're ready. On which Wi-Fi are you?
Yes.
On the guest? Yeah, it might take a while, I guess. What about our virtual machine? How many percent? How long more? Few minutes. Okay, so for everyone that does not have a virtual machine, Tomek is copying into the pen drive. It's really big, so it might take him a while, but he started when we started, so in a few minutes he should get his virtual machine. So if there's anyone that needs the virtual machine, just ask Tomek. Alright, the guest? Great, let's proceed. So let's create a simple Ruby file. Name it your way. I just go with cookielogger.rb. Just make sure in the race loop, because it's really important. Alright, let's go to the subline and edit this file. Right here. I've done this before, so I let you just retype this into your computers. And, well, the first two lines are not really complicated. You're just requiring the Sinatra and the Ruby logger. Nothing to worry about here. On the fourth line, we're just creating a new logger object, which will be globally accessible, but for the microserver, we don't really care. And the next few lines of code. Also, if you have a question or you encounter an issue, just raise your hand and Tomek will go through. Alright, so the next few lines of code are actually getting the cookie into this path, logging it, logging the parent's cookie, and that's really all. So make sure you type that, and it's important for you to create this file in the race directory because we're going to use this path to log cookies. And, well, the log directory is in the race root directory. So just make sure this file, the cookie logger, is in your race directory. You can see my path here. Alright? Everyone ready? Okay. Let's proceed to the terminal now. And the way you start your cookie logger is to just simply type Ruby cookie logger. And you may see that the Sinatra has taken the state of the 4567 port. And this is exactly when we will find your Sinatra application. Also keep in mind that we did not define the root directory, so going just to localhost 45671 won't work. And also in the second terminal, let's actually minimize it a little bit. Let's do the command to log our cookies. So they should be in log cookies log. I have to actually remove mine. Alright, and let's perform a simple request just here by going to localhost 4567 cookies, let's say 1.234. Okay, you will see the blank web page. It's not an error, it's good. You can see the get in your Sinatra application. And if you go to the cookies logger here, so tail log cookies log, I think you actually have to touch the log first. So yeah, let's create the log first, so Sinatra has access to it. We can later tail fit to see the live output of it. Let's go perform one more query. Nice and good. Log cookies log. Okay, the path is alright. The logger. Well, okay, seems fine for me. This one goes to 2.4. I'm getting the feeling that something is wrong here. I'm not really sure what. Let's go to the Sinatra application one more time. Okay, we're going to just debug it. So let's comment this out. Let's do a hello world to see if it really succeeds. Also, the thing for Sinatra is that you have to kill the server always if you change your code. I know it's inconvenient, but well, it's a micro framework. It has its price. Now, if you go to the cookies, whatever, you should see the hello world. Okay, nice, it works. Now into the logger. So I commented this out in here. I'm not sure why it doesn't work.
Where is the file? Where is the file?
The logger? The logger different here. It should go on.
What's the file?
That file? It should be the Rails root directory, so here. And you can see the log, the cookies log. And well, it should load the cookie. Where are my cookies? Let's save it. Let's restart the Sinatra one more time. Let's go here. You won't see hello world anymore, by the way. Okay, the cookies are being logged in. So nice, we have our server ready. And here's your website. Now, shall I stop here and show you code or something? Anyone lost at this point? Everyone fine. Okay, great. So you can see that the cookies are being logged in nice. No. Nice. Alright. However, this was us that performed the GET request. Let's get the user to perform the GET request. So we're going to go back here to our thread. And let's say cookies. And here's our attack. So we're going to open the script tag. We're going to create a variable with new XML HTTP request. We're going to call the open method, which takes the HTTP verb. In our case, it will be get. The path of our Sinatra application. If you have an issue, just raise your hand. Okay.
I can't see anything there.
I think so. Probably just turn on the lights. And also, if it will be better for you, I can do the presentation. Yeah. So probably it will be fun. Can you all read the code right now? It's okay?
Yes.
Alright, so just retype this with your comments down below. And, well, cross command. What it does, by the way, is it creates a new AJAX request. It uses the get HTTP verb, the path to our Sinatra server, which has to be running. Remember, it has to be running on 4567. And we're adding the document cookie property. document cookie property is well the cookie of our user, containing everything. If you steal this cookie, if you get this cookie and we change our cookie to this cookie, we can log in as basically any user that will see this command, which is bad. Also, this is really a sneaky and silent attack, because it really can't be spotted by the admins who are not programmers. Of course, they can open the web console and see the request, but if they are just being admins, they won't. So really sneaky attack. It allows us to become an admin by ourselves, by getting the cookie from the admin user. We can then log in as admin, give our user the admin privileges, and quickly edit these points so admin never sees anything. And admin will never know. So, yet it's sneaky. It's sneaky. Let's see if this succeeds. Everyone okay with scope? Everyone detected?
Could you show the comments and follow the command one more time?
Yeah, sure, of course. I think I got it right here. If you have any problem, don't recommend me help you, of course.
Okay.
Is it fine? Alright. So, let's do some cookies. Totally not accessible via the document queue. So, yeah, thank you, Rex. It's nice. Also, the HTTP only session cookie is the default in Rails. So, you can find probably in config session store, config session store, config initializer session store. You can check it. It should be here, the config initializer session store. And you can see here, just under it, there's a cookie store and the key is having phone session. So if you want another key, just change whatever's here. Alright. But it makes you wonder, are all cookies HTTP only in Rails? Well, unfortunately no. Only HTTP only cookie is the hacking phone session, which means that whatever cookie we will set, it will be accessible via the document cookie and it will be vulnerable for the XSS attack. So, here are the two methods of getting the cookie. At first, let's wonder about these comments. So, what I'm trying to do here now, I've seen a couple of the web applications I've encountered so far that they are storing the path I came from in their cookies. They want me to log in, and then after I log in, they are redirecting me to that path from the cookies. Well, it seems like a good idea, right? Let's say you log into shop, you see the product you want to buy, you have to log in. So you log in, and you rather want to be on the root page. You would like to see the product you're trying to buy. So, in theory, it's okay. However, I told you in the SQL injection that you can never trust your users. Anything that comes from user is not safe. The params are not safe, and the cookies are not safe as well. Because you can just change this cookie, right? You can change it to some malicious site, and user will be redirected to this malicious site. It's probably going to be, like identical shop with yours, except there will be an error message that something went wrong, please try to log in instead. The user probably will try to log in, giving us their credentials, their email and password, and will be a victim of the phishing. Anyone knows what phishing is? Everyone knows what phishing is. Okay, good. So it's not user fault by any means that he was reckless and he fell for that phishing. It's not his fault. The user is not supposed to look at your web browser, the URL. The user is supposed to look at the content, so it's not really their fault when you request. It's our fault that we haven't protected them. Let's try these attacks. So I'm going to go to the commands controller. Actually, no, I'm going to go to the foreign threads controller, to the show action, and I'm going to define a cookie. Let's say this way. I save the foreign threads controller. You can give me anything you want, any string, any name, whatever, doesn't matter. And now, when you refresh the page and presentation, oh sorry, not cookie, but cookies. My bad. It should be plural. So cookies, attack equals test attack. Let's refresh the page one more time. And you can see an attack cookie. And let's see if it's accessible. You see, there is no HTTP only flag. So it is accessible. What you can do is, you can do document cookie, and here it is. You can override it with just this, and if you look into your cookies, well, it will be overridden. And this sucks. So what you can do, you can also see that this value, the hacking from session, is signed. What signed means is that it's signed by the hash you will see here in the config secret CM. This is also the place to talk about the security data exposure, because people often tend to generate the Rails application with the Rails new. This creates this file, this creates the config secret CM, and people just tend, git add everything, git push, and they give away this little secret. And this is really important to not give away it, because the cookies are signed with this secret key base. In Rails 3, they are signed with the secret token that are in the config initializers secret token, and you can't commit any of it. So remember, in Railwaymen, we tend to just create the secret YAM example file where we just tell you the structure of it. So yeah, we just tell, in this file we just tell that there should be 3 main environments, each one with the secret key base, which is the example secret. And what we expect from other people who code in our project is to just copy paste it into a secret YAM and turn these example values into the real one. This is kind of our practice. So we advise you to do that as well. It's safe. And let's sign our cookie with this secret key base. So we're going to go back to the forum threads controller. To sign this cookie, you can just type .signed. And it will be hashed with your secret key base. Let's test this one. Also, let's remove these cookies. They are not really important now. Let's refresh the page. And you can see now, my string is hashed. Good. And also, when you will access your cookie, accessing it like that won't work, because it expects a signed cookie. So if you want to retrieve your cookie, you have to do cookies signed as well. So yeah, please remember that. Okay, so is there any way to do the HTTP only cookie? Well, it is, and it's surprisingly easy. In order to do that, you have to pass the hash of values, with the first key being value, obviously, and the second key being HTTP only true. This little snippet of code will ensure that our cookie is HTTP only and cannot be read with the JavaScript. Let's test. I'm going to save that, refresh the page. Oh, this is the old cookie. Let's remove that one, refresh the page. And you can see that my new cookie is not only signed, but also it is an HTTP only cookie. So whenever you're setting the cookie, please sign it and please HTTP only. It won't allow attackers to use it in the XSS attack. It's an empty string. So yeah, it works. Great. Here's a quick recap of what I've been testing. Going to load command desk. Thank you. text cookie is the most vulnerable. It's plain text. Anyone can override this. Anyone can read this. Don't use it. The second one is a little bit more safe. It's signed with our secret key base. Again, do not ever push config secret yarn into Git. It's a really bad idea. It's silent. It's harder to read it. However, it's really easy to override it. What can save you is the sign with the HTTP only drop. Now you're safe. There's no reading, there's no overwriting, you're good. So, we know that it's safe from cookies still if we do this HTTP only cookie, but is it really safe from all the XSS? Well, it can be. It can be with the help of this little word sanitize. If you add this into our application, in the app views, forum threads show, just this little word sanitize. Let's save the file. Let's refresh the page. We can close the web console for now. And nothing will work anymore. However, the links will. So it's really nice. It's nice because your user can have images, can have links, you can have all this cool user stuff, but the field is not really accessible to the XSS attack. However, the way the sanitize works is the people from the device jam, the platform attack, recently wrote their own sanitizer, which is smarter than the one they were using at Rails3, because often the XSS attacks are not really this simple. Often they are trying to do something like image source and here inject the JavaScript. So do like something JavaScript and kill alert, hey XSS. And if you try to pause it, it won't pass. It will display this alt attribute of the image, but it won't pass. However, real images with the real source will pass. So it's really safe. So, what I want you to remember from the XSS attack is to always sanitize your output. In fact, the Rails does it by default. In the Rails tree, there was a helper called H. So you're escaping your code just like H comment content. In the Rails 4, all content is escaped by default, so you don't have to do it. However, it is escaped the way that it won't allow links, images, any cool user stuff. So we added this HTML save method. But this opens the vulnerabilities for the XSS. So we have to protect with sanitize. And using this line of code, user has images, links, cool stuff, and you are safe. So whenever you're doing the HTML save, whenever you're doing row, always use sanitize method. And that wraps up the XSS. And one more further reading I wanted to check is this little article. It's really sufficient to explain all the XSS strategies to hack Rails. And after a little break, we'll proceed to the cross-site request forgery. And now I guess we have a break. So yeah, thank you for the part one. Everything clear?
Yeah.
Yeah?
I have a question.
Yeah, sure.
Since we are having the same origin policy,
Yeah?
are the cross-site script any issue longer? Because like the same origin policy doesn't allow to make AJAX requests to the other origin, right? So even if we inject some JavaScript, it cannot really do anything because it cannot leave the origin. So
You'll be surprised how few websites have this same origin policy set up correctly.
Yeah,
You will be really surprised. So yeah, we'll talk about this later. Now just stand up, stretch, have a drink. Thank you for attention on the part one. A nie, to stop this recording. No? Okay, bo nie będę się dzisiaj. No, okay. So after that short break, we return to the cross-site request forgery. Someone here said that content security policy is actually protecting us. Yes, it is, but many websites are not setting it correctly. So yeah. As you may know, Rails actually got this nice CSRF protection already. In every application controller you will probably see, there will be this short method, the protect from forgery. With this custom, it will be exception, null session, and some custom solution is also possible, I believe. And what it does is embeds a CSRF token generated from your session, and definitely from timestamp, into any request you make. So, yeah, thank you guys. It's really convenient. However, does it mean that the Rails CSRF protection is unbreakable? Well, let's jump to the HTTP verbs. You probably are familiar with most of them, like get, post, put, patch, delete. But there are some others. There is a get request, options, trace, connect. Those two are often used to negotiate the connection, and they are not protected. And the get is also not protected. The CSRF token in Rails protects the post, put, patch, and delete. Well, it makes sense, right? Because get request is not really meant to change anything. So does get, options, trace, and connect. They are not really meant to break anything. They are just getting, negotiating. The methods that change the content, create them like post, change the existing object like put or patch, remove it like delete, those should be protected. Like get, not really. However, there is one little pitfall in the CSRF protection in the Rails routing. And it connects with this little keyword match. Match is really dangerous method. Match is used to connect more than one HTTP verb to given path. So this little method will actually connect this URL to the updating comments, and to the Rails form you didn't have to add this via all, it was by default, but Rails form knows that via all is really dangerous and you shouldn't use it, and if you try to use it without the via all, your application won't start. There will be a security error, which is really good. But why? Why would anyone use this match? Why? Well, let's consider this use case. I've seen a couple of times that client request was that our API needs to be accessible both via the put and patch requests. And we have two solutions. We can just have duplicate routes with put and patch. It's alright. We can have match with save via option, and we can have the match with via all. And as you can see, the match with via all is the worst solution. It will get you fired. So do not use that. So let's do that little attack on the CSRF in Rails. We're going to jump to the code. You can git check out if you want. We'll see if something breaks. We're going to start in the config routes. Here there it is. And we're going to add this unsafe match method. So, match forum, the root first, I believe. Forum threads, forum thread ID. Do not forget the code here. The comments, the ID of the comment. We're going to match this code URL pattern to the comments update action. Actually, I'm going to split it with counter so you can see it better. Alright? Everyone got it? Okay, so let's try to restart the application. This is the cookie logger, right? Okay. And let's close the cookie logger. Let's close the cookie logger itself. And let's close the race application and try to restart it. Well, it won't happen. It will tell you that there is a security error, that you should not use the match method in your router without specifying an HTTP method. You can see even the instruction here, but well, people are people, very people who will do just this. Go via all. And it is only required in Rails 4. Often this error causes people to just get rid of match, which is a really good thing. You should get rid of match if you can. However, in Rails 3, there wasn't an error on the start. So there wasn't a requirement for the via all. And what does it mean is, well, you actually will have this get here. And you will abuse it. We don't have the comments update action yet, so let's quickly write it. In our comments controller, let's do quick def update. Let's search the thread with the ID. Let's search the command in this thread comments. Not finding someone. Let's update the command with the part that comes from the server. It's okay, let's redirect to the thread, as usual. Or you can just, it's going to be API, so let's do just cat 12. And if it's not okay, let's do like cat 500, because something went wrong. Okay, type this quick endpoint in your application. Let me know when you've done it. Alright. One more thing for the routes. Remember this via all option, because otherwise it will fail. So this, and yeah, it should be alright. Let's try to restart our Rails server. Unfortunately for us, because we're now vulnerable, it restarts properly. However, for the cross-site request forgery attack, we'll need more than one site. So let's start another Rails server with the bundle exec Rails server as well, but with the -p option being the port the new application will listen to, and let's just put the 3001. I think it will fail because there is a server bit, but we'll see. Yeah, the server is already running. So let's remove this bit. It's okay. Start the server once again, and it should work. In order to act like other website and other user, we'll use the private mode in our web browser. I'm using the Karol, so I'm going to do exactly that. Here I am on user1 at example.com on the localhost port 3000. I'm going to create a new private window, and I'm going to go to the localhost port 3001 and log in as a second user. So log in as user2 at example.com with the password being password. Again, you can find the authorization data here in the db6 file. So yeah, here it is. Alright, let's log in. Yeah, we can use the SQLe again. And let's say something like, hi guys, I'm Mila. So here is the user2 and example.com. Because those two applications share the database, they do not have to, but it's easier for now. When you refresh the 3000, it's also here. So what we're going to do now is to use the command from this user to change the command for the second user with the use of the cross-site request property. So because we are now protected from the XSS attack, we're going to remove this protection for now. And also this is a good time to talk about why you should care about the XSS injection too. Even if you're not rendering any custom user content or you just don't care, just don't be that guy that enables the CSRF. Because to enable the CSRF attack, you need two websites being vulnerable. First one, that will allow you to inject the JavaScript to do the AJAX request. To the second one, which have to not implement the CSRF protection. So yeah, let's remove this. This will cause this annoying color, right? Yeah, this will cause the annoying color. Alright, let's restart the page. We'll use the new thread. Because we don't really know what the alerts. So let's go to the root page. We can use the can be seen this time. Okay. And we're going to use the 3001 user to say something that can be seen. And we'll say, hi. We'll refresh the page here. Here goes the hi. Okay. So now, let's try to change this command to something what user 2 probably wouldn't like to say about himself. So how do we do that? We know that there is an exposed endpoint waiting for us, waiting for us just here. In order to use it, we need two information. We need the form thread ID, which unfortunately is in the URL. It is rather good practice to not have URLs, do not have IDs in URLs. Also, well, it will act positively for your SEO, for optimizing your search engine, to not have IDs in your URL, just have something that is easy to look up, like title, something like that. And we need the ID of the comment. This is a little harder to get. If we will not expose it, it's really hard to get. We will cheat, we will check in the database just for the sake of this attack. Another terminal then. Let's go to the console. I have a drink in the meantime. Let's check the last command ID. Okay, it's 20. And using this information, let's do a CSRF in Rails. So, again, hi user2, script. Again, we create the new HTTP request. Again, we're going to use the get, because we know that get is not CSRF protected in Rails. We're going to use the localhost 3001. This foreign thread, so the ID 6, comments, ID of the comment, and here you want to inject some kind of malicious content, like for example, change what he says to, no, I am stupid, for example. So let's open the query, and you can see in controllers that I'm requiring the comment and permitting only content. Well, that does mean that we have to encode this properly. So if you want to encode this into the URI that can be seen by the others, we're going to take comment array content equals, space is %20, so change to I %20 M %20 stupid, for example. Let's close the pod, close the HTTP open, and HTTP send it to the other side, on the other host we haven't ever seen. So let's do it. You can see that we added successful comment. There should be a request coming our way on the 3001. And this is 3000, I believe. Is it? Okay, let's just see if it works. It did not. Let's check the console actually. I know I encountered this problem before. And I am absolutely sure that we can actually go around it. Probably when this user refreshes the page. Because now it will be the same origin, right? Okay, so we respond with the status of 500. Let's see why. Because now we can see. And define method comment for formatted. Oh, okay, I see. It should be comments, not comment. I missed an S, sorry. But now it should work. Let's refresh it one more time. You can see there is no error. And if you refresh the page here, probably the query is running in the background, right? Yeah, you can see the update query being executed with the content from I am stupid. Unpermitted parallel content. Really? Okay, let's display the query. Oh, there are content. See? The quotes. Yeah, the quotes. Alright. So we have to modify our CSRF query. And let's do it by hi again. The script. Again, we're going to create a variable. We're going to call open with get HTTP localhost 3001 forum threads ID 6 comments comment with ID 12 query comment content without the quotes. That was my bad, I used quotes here, so without the quotes. Let's do it again. I am stupid, for example. Let's close the HTTP open. Let's call send. Close the script. And let's see how it works. Okay, there is another request. As the colleague here said, the content, the same origin, access control allow origin protects us here, but it won't protect this user who sees this page. And if you refresh, there should be a query in the background that actually updates the. Or there is an error. What? I think this is an old error because we've already seen it. Yeah, it's Google, I believe. Yeah, one more typo. Sorry, guys. Yeah, let's do it one more time. comment sub this time 20 comment content, same old story. Okay, from threads, comments, not quotes. Okay, now it should succeed. Okay, I know this will fail, but this should succeed here. Okay, this is 404, no fun. But you can see that here, we actually got the comment. We changed the content to I'm stupid. So if you refresh the page, well, sorry user 2, but we changed your comment. And probably he will never notice unless he browses his old posts. So yeah, this is one little CSRF pitfall in the Ruby on Rails protection. But in order to follow the rule, you have to use this match with the via all. So what's the correct way? Well, if you really would like this route to be accessible with the put and the patch, well, I guess you can do something like that. It's not very pretty, but it works. Probably the better way would be just to... Someone let me work, please. Probably the better way would be just to do post, duplicate this route to the commands update, if you really would like to, and copy it and go here, but with the also not post. It should be put and I have my user. Yeah, maybe. Put and here should be patch. Yeah, I should be got my insert. It's really dark and I can't see this thing. Alright, never mind. So yeah, just remember that via all is not really an option. If you really want to make route accessible with the more than one HTTP verb, please use the pull and patch. It will be better for you. So what I like you to remember from the CSRF attack is to, well, never use match unless you have to, and if you really have to use match, just use it with this save via option. Let's go back to the presentation then. You guys that will allow us. So what we learned today is that the Rails CSRF protection is not 100% safe. Well, yes, it is, kind of. Unless you're not staying close to the Rails guides. And if you read the Rails guides, the Rails guides, well, they'd rather not having you type this much. They present a whole spectrum of another solutions to achieve same effect without much. So stay close to the Rails guides, do not use much. Unless you really have to. Further reading. This is a very nice subject journal of the railsecurity.info. This URI is particularly useful, but well, it's telling me the same thing as me, that CSRF is great, it works, it tells you how to set your content security policy headers better in order to protect your site, but however, it won't tell you about this match pitfall. So yeah, good thing you come to these workshops. This closes the CSRF protection. Any questions to the CSRF? Not all your questions? We're fine. Okay, that closes the coding part, but we'll talk about the 7th point in the top 10 of us, about the sensitive data exposure. So, sensitive data exposure, what is this? Well, as the name says, anyway, you can have your data leaked into, well, attacker hands is bad. So how can it happen? The first point, the credentials leaking to public repositories. That's what I said to you earlier, sorry. I told you to not commit the config secret yam ever into your GitHub repository. Just do not. There are some more sensitive files, like config database yam. Also, please do not commit that to your GitHub repository. In Rails 3, it will be config initializers session store, not session store, secret token, that defines your secret token. Okay, you have to commit that to your GitHub repository, but not in the form of the plain string. I don't know, use the env, for example, read it from the YAML, use whatever solution you can to not commit the string into your GitHub repository. Just do not. You'll be surprised how many times application gets hacked because this credentials it. For example, when you have account on the Amazon Web Services, for example, for your images, something like that, and if you copy your Amazon Web Service credentials into the GitHub, they will actually detect it and they will tell you to remove them. They will tell you to change your API keys. Because they're scanning the GitHub for their own API keys to, well, protect the recklessness from other people. So even Amazon is doing it for your sake, do it for yourself. Do not commit. Do not commit the config files. Ever. Okay, lack of proper in-app authorization. What is the difference between authorization and authentication? Anyone? What is authentication? Come on, what is authentication? Yeah, the user logins. In short terms, yeah, that's authentication. What's authorization?
User can do something.
Exactly. So, well, point two could say lack of proper in-app authorization and authentication, or authentication. However, when we insert the device gem, we have this authentication in our back. Device gem is really okay, it's safe to use, so we don't ever care about the authentication. However, the authorization is something that we have to do by ourselves. There are some nice games that will help you do that, like CanCam, like Pandit. However, you have to write this code. There is no gem that will do the authorization all for you. You have to be careful. You have to let users see only what you like them to see, only what belongs to them, the post that they written, not their colleague. Authorization is really, really important. The third point, debugging information in production environments. When you're browsing the net, sometimes just open the console. Just open it for your own curiousness. And sometimes you'll encounter the console logs from debugging that came to production environment, sometimes containing information that it should be containing, sometimes having fun words with it. Well, fun words aren't really, that dangerous, but, well, debugging information can tell attacker how the website works. And it can tell attacker how to attack the website. So, whenever you're committing, sending to the production environment, just remove those console logs, remove those puts, remove it. If anyone ever get access to your logs, don't make them easier. Right? Well, for Rails it's kind of better because they have to get access to your logs somehow. But for the JavaScript, when you're doing, for example, like AngularJS application or something like that, you stick those console logs, user will see them just by pressing F12. So do not ever commit debugging information to the production environment. Okay, point 4. Access not restricted, wrong access privileges. It might seem like point 2, but it really isn't. Access not restricted is a situation when you have some developers. Let's say you have like 4 developers that work with you on the project. Project goes live, you obviously have those live account for looking at the production, for example, stats. It's okay. And let's say that one of your colleagues just quits the job. They go to another software house. You really, really should remove their account. Because they are no longer in the company. They could do some bad things in order to, attack you if they would like to. Just strict access privileges, always. Someone goes out from the project, remove their account. houses are rather nice, but yeah, protect yourself. Just protect yourselves. The fifth point, the lack of encryption. We touched this point in the cookies, where we cite our cookies. In Rails, we have this nice password hashing done by ourselves. However, there is one gem, the bcrypt, that does it better, because the bcrypt algorithm is stronger. So yeah, use the bcrypt. Use has secure password helper. It's really good. And whatever you're showing, just encrypt it. Of course, not the content of your website, but cookies. User can see cookies just by pressing F12. Encrypt them. That makes them easier. The sixth point is what we will be talking later, is the API responses containing sensitive data. As we already know, this allows us to simply generate an API with to JSON to XML. It's really easy. What we can do to protect ourselves? The code reviews. The code reviews are really important. It is what we do in the Railwaymen. Tomek is my code reviewer, by the way. Even if I forgot something, or I am reckless because I haven't written copy yet, Tomek will spot it. Tomek's reviewer will spot it. So yeah, just code review each other. Because, well, it's not only about spotting the vulnerabilities. You're learning from each other. Maybe he knows something that I don't know, like some cool active support method. I will learn that from his code. So yeah, get someone to code review. It will be helpful. We will learn a lot. Point 2, careful authorization. There are some solutions I told you earlier that can help you authorize, like CanCam, like Pani, but you can also authorize this for yourselves. It's really easy. If the user is viewing the post, just make sure that the current user ID is the same as the post.user ID. Just make sure that user only sees what belongs to them. The fourth point, well, simple, encryption. Encrypt everything you can. Yeah, just has secure password helps a lot. Of course, do not ever store plain password in a database. Well, it's obvious for us, right? Well, it may be not obvious for the developers that work from another country, like USA. It happens. Sometimes it happens. It's really bad. So, yeah, just remember about that. And the fifth point, last but not least, API exposing only necessary information. And we'll touch upon that now. So, how do we create a secure API? Well, Rails got this nice to JSON or to XML. Those are really convenient because without writing much code, I can just do a JSON API, right? I can just render JSON, any model to JSON, and I got all the information. Nice! So, thank you Rails for easy APIs with to JSON. Well, no. No Rails, because you're creating the vulnerability. Let's see this code. This is what Rails generators used to generate in other Rails versions. Now it does not. Now it uses the Rails API gem, which will be the default API solution in Rails 5. But it is what Rails generators tend to generate. Well, it doesn't look nice. There's this render JSON threads. Well, convenient. And this is the output. It renders everything. You probably would like to render only, for example, title for your API, but it renders everything. It renders ID, timestamps, anything you will put in your model will get JSON. And as you probably know, users can inspect JSONs that their web browser receives simply by pressing F12 and going to the network tab. They will see the response. They will see the whole JSON. And they can use it to take advantage of your application. Let's treat the access, for example, to only title parameter. Well, okay. We added this that only column title to JSON. Well, okay. It works. Nice. But this code, it's not pretty, right? It's clumsy. It works, but it's clumsy. Couldn't we think of something better? Something nicer? Something, I don't know, code prettifying? There are two gems that are popular right now for building pretty and secure APIs. There's a JBuilder and active model serializers. And we will talk about the differences about them. So JBuilder probably will be easier for you to learn. It is like ERP and HAM approach, the template approach, that you just get another template. It's ERP-like. It will be easier for the newcomers. It is flexible, no doubt about that. But it is hard to test because you're just creating another form of view. And well, you tend to not test your views, right? So yeah, it is a little harder to test. The test may become clumsy because, well, if your application exposes an API, well, that's an important part of your application. You want it to be tested. And it's clumsy to test views. So yeah, it may be hard to test. And there is no adapter for the JSON API. JSON API is a schema that is in its first version, and it defines how the proper JSON API should look. There is a gem, of course, the JBuilder, I don't know, the JSON API, something like that, but it just gives you the helpers. You have to still write code by ourselves. So, yeah, JBuilder may be easier to come to, but it's harder to test, and you have to do a lot by yourself. The other approach, introduced by active model serializers, is the object-oriented approach, because active model serializers are, well, Ruby object. They are classes. Since they are classes, you can define some decorating methods in them. And probably this is the place where decorating methods for your API should be. Not in the controller, not in the model, in the place that helps you render them. And well, it happens to be a Ruby class inheriting from the active model serializer. It is flexible though, it is all Ruby. Well, I'm a Ruby developer, of course I know how to write JSONs and so on, but it's just Ruby code is prettier, right? When it comes to JSON. It's easy to test because it's a Ruby class. You can test like any other Ruby class, it's fine. And they already got this nice adapter to follow JSON API version 1.0 schema, which is nice, you don't have to do it by yourself. And last but not least, they have this documentation in Yard. Anyone know what's Yard? Never heard about this? Yard is Yay, a Ruby documentation tool. This is actually the acronym, the Yard. Yard is not really used in the Rails applications because, well, people tend to not comment controllers. Actually, there is no reason to comment controllers. However, there will be a time in your Ruby developer career that you will have to write a gem that other will use. And well, it's good for this gem to have proper documentation. And the Yard tool can help you with that. So yeah, check it out when you will be writing your own gem. Check it out for the documentation, it's really good. Alright, so quick summary for these workshops. These are the things I want you to remember from this workshop. I want you to never trust anything that comes from user. Not only params, but cookies, headers, anything that comes from user. Nothing that comes from user is safe to use. Never. Point 2. Always sanitize your HTML output. Especially when you've seen rendering the links or images from user. Take caution, always sanitize it. Also, it will prevent your application from being the CSRF source. So yeah, be a nice guy to other developers. The third point, be careful with match routing. Just don't use it if you really don't have to. The fourth point, inspect your outputs. Return only necessary information from your API. Not only from your API, but mainly from your API. Always inspect what your application, what logs, what API contains. For example, let's get this nice logging that when you're logging in, for example, with the device, you check the logs, there will be an email, but the password will be filtered from the logs. This is really nice. However, it works only for the password with the device. If you would like to, for example, take some bank data, if you want added to those filtered params, they will be visible in logs. And imagine someone getting their hands on your logs. They will have the banking data with the just simple use of graph. So just inspect your outputs. API logs, inspect what goes there. And the last but not least, get someone to review your code. You will learn a lot. They will keep you safe. It's really good. So yeah, please remember these things for this workshop. Thank you for your attention, of course. If you have any questions, ask them. Of you?
What about HTTPS? Should you say HTTPS and all the document pages?
Yeah, of course. HTTPS is great. And well, there are some cheap ones. Like for $5 per year, I believe, you can get an SSL certificate. It's really cheap.
And remember to use TLS instead of SSL. Yeah.
Yeah. It's really important too. Whenever you can. And well, you can follow us on all these links. This presentation will also be posted on our Twitter, I believe, and you will take care of that, of course. And you'll probably go to some slideshow, slides that we have, something like that. You can check our blog. I sometimes post info about security attacks there. If you want to visit us, you're welcome, of course. There's the address. So, yeah, I think that's it for today. Thank you guys for that. Thank you, questions. Thank you.